Okay, today I'm going to talk to you about fractional distillation. So, fractional distillation is a method of separating the different components of crude oil in order to get different fractions which can be used for different purposes. So essentially, crude oil is a big mixture of different hydrocarbons. Some of those hydrocarbons are long, so they have a long chain length, some have shorter chain lengths, and some have very short chain lengths. So crude oil is a big mixture of different hydrocarbons with different chain length. When they're all mixed together as crude oil, we can't use these different parts for their particular purposes. We need to separate them. And that's what fractional distillation is. It's separating the different parts of crude oil based upon their boiling point. So it's using the different boiling points of these different chain lengths in order to separate them. The longer the chain length, the higher the boiling point. Remember, boiling point is the temperature required in order to turn a substance from a liquid to a gas. So this is how it works. First of all, what you do is you feed the crude oil in to this particular part here of the fractional distillation column. Here is where it gets heated. So a lot of heat energy is provided, and then the oil goes into the fractional distillation column. Now the whole of the fractional distillation column works because at the bottom it's hotter and at the top it's cooler. And as you go up the column, there's a gradient in temperature. It goes from very hot to much cooler. At each level it gets slightly cooler the further you get up, the further you go up. So when you heat the crude oil, the vast majority of the parts of crude oil turn from a liquid to a gas. So they evaporate and travel up the column. So they go up like this. Now at the first step, bitumen is one of the fractions of crude oil made of very long chain hydrocarbons. So it has a very high boiling point. As a result, this doesn't evaporate and it just comes out of the bottom as a liquid here. Bitumen can be used for surfacing roads, and it's made of 70 plus carbon atoms in the hydrocarbon chain. So the rest of the fraction, so all of the other parts of the crude oil, all evaporate and they all go up the column. Now here's the clever bit. At each different part of the column, we reach the boiling point of one of the different fractions. So next up, we reach the boiling point of fuel oil. So what happens at this stage here is fuel oil condenses and it turns from a gas back into a liquid and it comes out here. The reason why it does that is it's slightly cooler than the very hot part of the fractional distillation column at the bottom. So this is where the fuel oil comes out. Now fuel oil could be used as fuel for big ships, and it can also be used in certain power stations as well. Now this fuel oil is made of chains which are 40 plus carbons in the hydrocarbon sequence. Now remember, at this temperature here it's still pretty hot, so most of these other fractions are still in the gaseous state, they're still gases, so they continue to rise up the column. As we get to the next section, the next one condenses because it's that little bit cooler. So at this stage, we have diesel oil, which condenses. Now diesel oil can be used basically in fuel for some cars and larger vehicles as well. So I'm just drawing a quick simple diagram of a lorry right here to show that. So again, we get the idea that at different stages, these different fractions condense and come out. We can then use the fraction for their specific jobs. So diesel is basically hydrocarbon chains, which are around 20 carbons in the chain. So we've just got 3 more fractions to look at. Again, at this stage, these fractions, because they've got a shorter chain length, they are still in the still gases. They have not condensed yet, so they keep going up. At this level here, we have the next fraction, which is called kerosene. So they're hydrocarbons which are similar, have similar boiling points, and they have around 15 carbons in the chain. And we could use this one, use kerosene, basically as jet fuel. So fuel for aeroplanes. So that there is kerosene. So we've got 2 more fractions to go. So next up, we reach the boiling point of petrol. And petrol condenses at this stage here. Now petrol could be used for fuel for cars, obviously. So that's the worst car I've ever drawn. But this, the length of petrol is about 8 carbons in the chain. And finally, the gases that go up out of the top and they don't even condense, they just stay as gases. A really short hydrocarbon chain length is LPG. Now LPG can be used for domestic heating and cooking. So they basically stay in the gaseous form and come straight out the top of the fractional distillation column. Now these are around 3 carbons in length in terms of the chain. So to summarise, fractional distillation is a way of separating all the different hydrocarbons in crude oil. It depends on their different boiling points. The longer the chain length, the lower out of the fractional distillation column it will come, due to them having a higher boiling point. And these are all of the different uses of all of the different fractions. Thank you.